All right, so here I am providing some example problems. This is from last year's quiz. So this is what I provided last year. This isn't a quiz. So go ahead and read it. Okay, take a pause. You can read it. I'm not gonna read it to you. All right, so here, based on that reading, right? You should ask yourself, what's the observational unit? Okay, and ideally you should be saying a something. And you notice I say singular. Let me see what it says. A small retailer. Okay, a small retailer. And on that small retailer, what are we measuring? What's the variable of interest? Okay. Ideally, you should say additional sales tax. Okay. Ideally, you should be pausing as I do this. Okay. What type of variable is the variable of interest? Right. It's quantitative because you're measuring money. Okay. You can add, subtract, and multiply by it or to it. What's the parameter of interest based on the above the description? Ideally, you should say population mean, mu, and more specifically, the population mean of additional tax revenue. Actually, that should be more of in the U.S. Is it U.S.? Yeah, in the U.S. In the U.S. Okay. Okay, good. What does 2,350 mean or denote in the above description? Right? From here, what does this value mean? Ideally, you should say the sample mean. Okay, that represents the sample mean. Okay. Now this one is actually quite interesting. Go again. I don't want to read to you. I think that in terms of practice, you should try to read it yourself. Okay, so magazine guy. All right, so here I did some side work, and so I already know my point estimate is going to be 0.274 because it's the proportion. Okay, those are the individuals that are interested in the actual this new feature. Is it the new addition? And then my standard error, right? This is really just let me say the square root of P or hat P times right 1 minus P or 1 minus hat P, and then this is and then this is all over N. So sorry, I gotta move this to the top. So that's how I got that answer. So P hat is already given to you, which is a point estimate, 0.274. You do 0.274 times 1 minus 0.274 divided by 500. That's what I did here. And then this is my standard error. So this standard error denotes how much does my proportion vary from sample to sample. Okay, so ideally we should remember that from our previous stat class. If not, learning hours. Okay, so that's that. And we can use this information to find the confidence interval. Okay, so in terms of the confidence interval, what would be the lower bound? You'd first find, at least state the point estimate and the standard error. Oh, you note that I already did that already. Find the margin of error based, so it's the standard error times the critical value. I gave it to you already, and then you find the lower bound by taking the point estimate, what we found up here, 0.274 minus the margin of error, and 0.24127. Okay. Ideally, any volume between 0.24 and 0.2422 would be accepted if this was on a quiz on Canvas. Okay. You think about the upper bound as the same kind of logic. Okay. The critical value, margin of error, right? And then you just add your point estimate plus the margin of error. So therefore it's 0.230. Now this is where it gets kind of important, or well, it's even more important. Explain what this confidence interval means in words. And so in terms of words, I'll say it twice here, but I prefer the second one. So what I mean by that is that the confidence interval in terms of its in theory in this example is an interval of plausible values for the population proportion of current readers interested in the launch of an online edition. In other words, therefore, we are 95% confident that the population proportion of current readers interested in the new launch of an online edition is between 0.42 and 0.3. Okay, so that's how you say this in words. Okay, that in the second sentence is what I'm after because it gives the numbers, it provides the actual lower bound and upper bound. All right. With that being said, when is it possible to make a type 1 error? This type 1 error only occurs within hypothesis testing. Okay, and this is hypothesis testing. If it's hypothesis testing, it's either you're going to reject the null hypothesis or fail to reject the null hypothesis. And a type 1 error what a type 1 error is the probability of you rejecting the null hypothesis given the null hypothesis is true. So this is only when you reject the null hypothesis. Okay. So if we say that the population mean of GPA is 3.25, we're guessing at it, and based on our data, we actually rejected it, right? We could be making a type 1 error because we're saying that the GPA is not 3.25, but in reality it is. Okay. Which of the following statements is true about the T and Z distribution? If the population deviation is known, we should use the Z. If the T distribution and that the T distribution approximates the Z distribution. Okay. And so here, with this example, consider the purchases that I made last year on Amazon as the population in a study. All right. Here, I'm asking you state 2 categorical variables that could be recorded on these purchases. So ideally, you should pause it here and think about this. What are some categorical variables on the purchases? One could say the color of the item. Was it delivered on time? Yes or no? Okay. Color items, categorical. Delivered on time is categorical binary. 2 quantitative variables that you can measure is the price of the item and how many days it took to be delivered. All right, so I'm pretty sure I'm going to post these. I should have said this in the beginning, but you would have known this by the time you watch this, that I'm going to post these notes that are empty. So you should have them. Okay. All right, thank you. Have a good one.